You're watching the Business Channel, creating business class programs.
To talk about computer-aided engineering, computer simulation, I'm joined by the Managing Director of Wilde Analysis, David Deakin. Can you give us an overview of your organisation, a thumbnail sketch of the kind of business you do?
Yes, of course. We are basically a consulting engineering organisation specialising in computer-aided engineering or computer simulation. This is based really around technologies such as finite element analysis, computational fluid dynamics and reliability engineering. We've been going for around 30 years now, and essentially what we're doing is trying to help companies to improve their products and processes using these sort of technologies.
How important is the successful application of these technologies to UK manufacturing?
Well, we believe it is very important. Of course, all these things are a matter of opinion, but in our opinion at least, using these sort of technologies does allow us, or helps, is part of the ingredient to help us to compete with the low-cost economies, or the SMEs to compete with those low-cost economies. If the cost of producing parts is predominantly labour cost, then we are never going to compete, I would suggest, with the low-cost economies. But if on the other hand, a lot of the cost is associated with the methodologies and the developments of those methodologies producing those parts, perhaps the high integrity parts, the more demanding parts, then I think the use of technologies such as simulation to make sure we optimise those processes is a vital ingredient and something that I think SMEs should be encouraged to do more and more.
FEA. Tell the uninitiated what that is.
Okay. The acronym stands for finite element analysis and essentially is normally used for, well, for instance, one application, structural mechanics, so predicting the structural integrity of components, of structures, anywhere really where you can represent things by a particular set of equations you can solve using finite elements. And you're going to ask me about computational fluid dynamics next, I suggest, CFD, which is really the fluids equivalent of it. So here we're looking at not predicting how a structure will behave under load, but perhaps how a fluid will behave under certain pressure and flow character regimes.
And what about reliability engineering, the overview?
Reliability engineering is slightly different in the sense that rather than being a numerical method, what we're doing now is using statistical methods really. And we've got involved with this in the last few years as a way of looking a little bit more at for instance, the aftermarket behaviour of components. So we might be looking here, a very good application of it actually, is to predict the warranty risk associated with using a particular component, a particular design, by analysing the data. And reliability engineering and some of the tools in there is used for that. It is quite a broad subject. There are many other applications, but that, I think, fits in quite nicely with the current topic.
From your perspective, do you think there's been a revival in UK manufacturing?
Yes, I know there have been tough times. We're very fortunate as a business actually. We have continued to grow throughout the recession, not at the rate we'd planned to, so it's not all been good news, but we have continued to grow. And I think that's possibly because we're aiming at the very high end, the high-tech end of engineering. And I think that that's something that as an economy, as a manufacturing economy, we'll be well advised to do. More and more companies should be looking to addressing that high end. And if they do, and I think they are in most cases, then I think we're in a very good position to compete with the rest of the world.
Are we? Does the UK have the skills to compete and to take advantage of the revival?
I think yes, there are some challenges there. I think it's very important that we don't lose sight of the fact that we need people at all levels within the engineering industry. We need to be developing apprentices. Apprenticeships have a little bit gone out of fashion, I think, in recent times. I think that's a shame. We also need to develop professional engineers, of course. We're often looking for graduates to work in our organisation. That in itself creates some challenges, particularly getting graduates who are security cleared to work on UK-only type applications. There are some challenges there, but also an opportunity. And I do believe, given the right, if we all make the right moves over the next few years, I think the UK is very, very well positioned to not only survive, but be a leader yet again in the manufacturing industries.
Do you think the future of UK manufacturing relies more on technical or on manual skills, or is that a simplification?
I think the future of manufacturing, UK manufacturing, lies in both the development and maintenance of both the technical skills and investment in the technology. It's very important that we've got the same technology as the rest of the world. Of course, technology is available to most parts of the world, so that in itself doesn't really set us apart necessarily. But I think that, coupled with good technical skills to drive that technology, to interpret that technology in a very effective way, is vital. And it's certainly vital in the simulation market.
Where do you think the government's placed itself? Are government decisions helping or hindering the growth of UK manufacturing?
Well, I know that the current government is very keen to encourage manufacturing, and that's, as far as I'm concerned, a breath of fresh air. I think one thing that is difficult, and the particular part of manufacturing that I'm interested in really, is the research and development, the R&D type activities. We help a lot of companies who are working on those projects and indeed get involved in some of those projects ourselves. There are some funding schemes around to help companies to do that. The one thing I would say is that I think within the SMEs, the smaller organisations, there's not that much knowledge about how best to get those funds, how best to make use of those funds. So I think if the government could do something, it might be to educate the people and make it easier for them to access that sort of funding and help.
One aspect you talk about is the service of providing from conception to afterlife. How does that work?
Well, traditionally, the technologies that we're involved with, finite element analysis, computational fluid dynamics, have been used to check, well, used in the development of the products, typically during the design process, which can often be quite a way into the actual development of that product. It's well proven that the best payback, the best return on investment from this technology is achieved by using the technology as early as possible in the design process. So that's to say at the concept stage, possibly before any drawings are done, just when they're just ideas in people's heads. So using the technology then, changes can be made very efficiently, very relatively cheaply. Does involve companies thinking a little bit different about their design process, but something we're very passionate about. And moving to the other end of the extreme, I've already mentioned earlier about the aftermarket concept of using statistics to be able to predict warranty life. If we can do that, then really we're looking at a complete life cycle, modelling the components, the manufacturing processes, etc., throughout the complete life cycle.
How do you monitor quality control in your services?
It's a very important aspect of what we supply, and of course, bearing in mind we're supplying both the software, the consulting and the training services. All of these services and products are covered by ISO 9001, so we operate a quality management system which is very important to us. But more than that, we need to make sure our staff are up to date. That's very important. This is a fast-moving technology. They're very enthusiastic to be up to date, but to do that as a business, we need to encourage them to continue their professional development, to go on graduate training schemes, to be members of the engineering institutions. So techniques such as that. How
do you ensure your staff are trained like that? How do you facilitate that?
By encouraging them to really, a lot of self-learning. There's a certain amount of self-learning goes on. They need to read around, they need to be aware of the technologies as they're developed. As resellers for a number of leading packages, we are fortunate to get vision of this very early, and that's important that they learn that. And then, of course, we encourage them to take part in institutions, seminars, and make presentations at institutions, and really everything that's involved in the technology, we should be involved with.
David Deakin, Managing Director of Wilde Analysis, thank you very much indeed.
Thank you.